Hello. So, as the title suggests, it's about introduction on everything around Android. Let's head start to the agenda. So, agenda is to get you started on like everything towards Android. So, like Android mobile operating system, Android app, and Android apps unboxing, Android app development platform, and the emulators which come from Android to get your app tested quickly locally on your laptop. And Android device administration is a nice app, good to know. And we'll also see a couple of sample apps if we are left with the time. Okay, so let's dive into it. So Android is kind of like a common knowledge. So it's a mobile operating system based on Linux kernel, currently being developed by Google. It has a slight history. So it was initially built by a company called Android, which was financially backed by Google and later bought in 2005. And so Android was unveiled in 2007. And at the same time, Open Handset Alliance was developed. So we'll talk about more about this later in the presentation. Let's move on. So the main hardware platform for Android is ARM architecture, for which it was developed for. So ARM v6 was what it was targeted for, but later we had ARM v7 and v8, so on what the Android runs. And later the official support was added for x86, the Intel x86 and MIPS architecture. And with the recent Android Lollipop, we have support for 64-bit variant of all the platforms. Okay, so here are the list of the companies which develop the okay, so here are the list of companies which develop the actual hardware for running the Android mobile operating system. So Acer, Asus, HTC, Huawei, LG, and so on and so forth. So this is the list of the companies which made the Android hardware, the hardware for the mobile device and tablets. Okay, so Google needed to manage the hardware development and the way it runs. So they started something called as Google Nexus. So it's a flagship Android product wherein Google manages the design and development and marketing support for these devices. But actual manufacturing is being carried out by original equipment manufacturers like the companies which I showed you earlier. So Nexus One was the one with which it kind of started. It was developed by HTC, and Nexus S by Samsung, then Galaxy Nexus by Samsung, then LG pitched in and they created Nexus 4 and Nexus 5, and Nexus 6 is currently with Motorola. And Nexus 7, these are the tablets now. So these are being developed by respective companies. So Google actually creates the final spec for the hardware and is being developed by these companies which are named here. Okay, since the time Google actually released, the initial release was on September 23rd, 2008. They codenamed it, they actually codename all the versions of Android operating system on suites and confectionery. So here the list of those versions which have been created. So the latest release is 5.1.1 Lollipop. Okay, and you understand that with each enhancement to the operating system, they've given more and more power to the app developer in terms of API. So with each release of the mobile operating system, they have been released like some new addition to the APIs. You can see the list here. So starting with Cupcake at API level 3 and till now, which is API level 22 at 5.1 when I'm recording this presentation. Okay, let's quickly walk through on how the screens look like in history, just to review a history a bit on how Android did and what were the major releases, what were the major things which were released with each of the Android platform. So Android 1.5 Cupcake, it has basic functionality of a mobile phone, and then they released 1.6 Donut, which was called as Donut. It also had the basic and like far more enhancement than the previous one, and later they released Eclair. So Eclair made you add multiple Google accounts, and this is the release wherein the official support of Microsoft Exchange email came in. Bluetooth was being supported, and multi-touch event was added here to be actually be able to support gestures and other things in the future release. So in Android 2.0 Freo, which is like short name of frozen yogurt, Google release push notifications. So now the app, uh, so the app server can send small messages towards the mobile, towards the user devices. Okay, and Adobe Flash support was added. Chrome JavaScript engine was integrated to the mobile browser. Microsoft Exchange, the email support of Microsoft Exchange, there was a lot of security enhancement, including so Microsoft Exchange give you kind of a capability which is about the Android device administration. So it lets you completely wipe your device remotely over the air. Installing apps on SD card was made possible with this release, Android Froyo. Android Gingerbread. So by this time, there have been a lot of talk around the performance of the code and also in terms of security. So for both these concerns, Android make it public, the native code development, so you can write code on C, C++, and NSC was released. At the same time, it was difficult for users to actually manage their downloaded files. So they released an app called Download Manager, with which you can get access to all the downloaded files from your browser or kind of any app. Okay, and they release an app to so that user can manage the power management capability. So users can see how much an app is consuming in terms of battery power. The next release was Android 3.0 Honeycomb. This is the the first release for the tablets. So it's kind of a made history here. So this is where Android started supporting tablets, and they made a major change. They kind of a rework on the API. So initially they had something called as activity, which is kind of a page on which you lay the UI, and they had to add fragments because of wider and bigger screen, so that make a screen do lot more than it was possible with the smaller phone devices. So we'll talk about this fragment classes later in probably the second part of this series, and that's where they officially started supporting multi-core processors. Okay, so just as I was telling you, so phone had this behavior wherein if you have to show the list and the details, so you click on any of the item on the list and the details will appear. If you click on another item, so you'll have to go back and click on another item to bring the detail on the other item. So it was not so convenient and not so performant. So that's why they added fragments so that you can have both. So you have two pages, two related pages on the same activity or same page. Okay, Android 4.0 Ice Cream Sandwich came with a nice feature of face unlock. So you just show your face to the camera and it'll open if it recognizes you. Android 4.1 Jelly Bean, that's where they actually standardized on a lot of things, the buttons, the soft buttons and other stuff. Android 4.2 Jelly Bean, lot of improvements to the platform, lot of new APIs came in. Android 4.4 KitKat, Android 5.0 Lollipop. So this is where we'll dive into this, but just to give you a heads up. So Android apps run on something called as Dalvik virtual machine. So with Lollipop, they kind of renamed it with Android runtime. There have been a lot of enhancements towards to make it more performant. But this is what is going to be called now, like after Lollipop, is the Android runtime. Support for 64-bit CPUs, I talked earlier in the first few slides. Material design came to give a better look and feel to the UI. Project Volta, which was there in the development for a long time, got released for the battery life improvement. The most latest, as when I was recording this presentation, is 5.1.1. They came up with a nice feature where if you add your account, your Google account to your Android device, and you can fix it. So that means even if you reset to the factory settings, the device will still demand the same account back, or else it won't log in. Okay, this of course is kind of a common knowledge that Android apps are written in Java programming language. However, they run on Android's own Java virtual machine, as I talked. So they don't run on JVM, Java virtual machine. They actually run on something called as Dalvik virtual machine. We'll talk more in detail about why they needed Dalvik virtual machine to actually run the apps. Why not JVM? Is towards like performance. Okay, so because the bytecode, if you see the bytecode, what is generated by Java program for JVM is very different than what you see for Dalvik virtual machine, and it kind of clubs to actually reduce the memory footprint of the program and do a lot of things to make it more performant and less CPU and memory consumption. So we'll talk more about it when we see the bytecode bytecode differences and other stuff, and what was the rationale behind creating Dalvik virtual machine in later in the slides. Okay, so this is how it goes. So Java source code is compiled into Java bytecode and to run on JVM, but wherein we have to run on the Dalvik virtual machine, there's a Dex compiler which comes with the part with so as a part of SDK tools, so which will compile your dot class file into .dx, which will convert all your Java dot class files into something called as Dex file, which will finally run on the Dalvik VM. Okay, so the Android SDK tools basically compile. So you understand your app comprises of a lot of other things, not just the Java code. There will be images, there will be layouts, there will be there will be strings, and there will be a lot of things which will be there inside them. So everything gets packaged into something called as APK. There's a suffix for the APK, so .apk, which means the Android package. So you just have to install the APK on your device, and your app gets installed on the device and ready to use. So the Android SDK tools let you compile your source code along with all the data and resources file into a file called APK, which is kind of a zip file. So you can take a APK, you can unzip, you can view inside, but not so much, because the Android SDK tool will convert a lot of the files into binary format, so it won't be much of the use, but it's a zip. So the AP, just to give you a quick look inside the APK, how the Android SDK tools will lay down the resources and the .dex file I talked earlier, the uncompiled resources, which are normally the images, and the resources which it can compile to make it reduce, to kind of reduce the size of the app, just like a string and the layout XML files for. So the layouts are the actual UI which will be displayed on top of an activity object. And there is, of course, a binary version of Android manifest file. So Android manifest talks about all the components, all the things which you have used inside an app, and to actually kind of explicitly say what kind of permissions are required to run this app, which user will have to grant in case there is something which is dangerous. And it also will talk about the permissions which are required for any other app or for any other functionality to invoke like anything inside this app. We'll talk more in details when we talk about security and other app development sessions. Okay, so this is how the whole flow goes like. There's an Android project which you build on the IDEs, and it will be compiled and packaged into an APK. It will be signed, and it will be installed on the device. It will normally be with the Google Play Store, but here I've given as ADB, which is Android debug tool, which you can install on your device and emulator during development. So it's quick. You can do all with the ID. We'll talk more about this further in the slides. Okay, so just a quick view on what comprises an app. So apps are made from these components, these 5 components. So Android will instantiate and run them as needed, but this is what it is. So like the first one here is the activity, as I talked about. So activity is just a UI. It's a one UI wherein user performs one action. And service actually takes 2 forms in Android. One service is to run on the background. You can configure to run in the background. The other form it takes is kind of pretty much similar to web services. So it stays there unless another app requests some service and gets the response back. So it works like that. Content provider is kind of so it's kind of a database which an app creates, but less is accessible to other apps. For example, contacts. So your contacts are like accessible to other apps. They can just view, they can do addition, they can do deletion from your contacts list. So it's kind of a central database which an app manages, controls it, but the other apps are given permission to work on it. Broadcast receiver are the components which will receive the events coming from the system or coming from another app. So take example that you received the SMS, you received a MMS, or you received a call. Those kind of events, and even the events like network going down, Wi-Fi coming up, user going away from the device getting locked. So those events you can listen to, and system will make sure you receive an event whenever those happens on the device. And intents are usually are the components which are not per se a component, but they are used to actually interact between these components. So activity to activity, or activity to a service, activity to a broadcast receiver, likewise. And intents are also used for communication between app to app. So these are small messages which you can pass to another app, so another app can take some action. Okay. There's one peculiar thing about Android app framework. So app provide multiple entry points. What it means is, so all these components make as a complete whole new entry point. So any other app can invoke these components inside the other app. Okay, and apps, when you start designing these apps inside an IDE, so apps can adapt to different devices. So Android project per se will take the images in different formats for low pixel density towards high and extra high density pixels. So you just give all the resources with the same name, and Android will make sure that they get picked according to the device wherein it runs. Okay. Okay, so this is the same thing as I talked about, that 3 of the 4 components, activities, services, and broadcast receiver, are activated by intent. So like as I talked about, intent is actually to actually open or work on these components. It's just a small async message which you create so that the activity of the service or the broadcast receiver is brought up to do their work. Okay, as I said during agenda, that we have to talk something called as application sandboxing. This is where the Linux part comes. Okay, this is where the beauty of the Linux comes, so that it kind of secures your app. Let's see how. So once the app is installed, it runs in its own security sandbox. Okay, so we know that Android is based on Linux kernel, and Linux per se is a multi-user Linux system. So each app is a different user here. System assigns each app a unique Linux user ID. This user ID doesn't change during app's life on the device. This user ID is only used by the system and is unknown, completely unknown to the app. App doesn't have any API to query this user ID to make use of it. No, it's completely unknown to the app. It's only the system known user ID, and system can manage it. Okay, and systems kind of sets permissions for all the files which this app is going to create or will create or have access to. So it's based on the user ID. So it's just like your Linux machine, wherein you create the files, no other person can access it on the same machine till the time you provide the access. So each process has, and even the Dalvik virtual machine, which we talked about, is kind of isolated to that process. So Android will bring up a process which will run the Dalvik virtual machine, and the DVM will run your app inside that isolation. Okay, this is something. So we have talked about that app-to-app communication in Android is kind of cool. So one app can invoke a functionality of another app, but app runs inside their own processes. So whenever you demand a functionality out of another app, Android makes sure that it brings up a process, and that process runs the DVM, DVMs run that app, and then the particular component you ask for. Now you surely say that this looks like a slow, because this will, so every time you request some functionality from an app, it will have to bring a process, and process will take time to create, right? You'll have to bring DVM, you'll have to bring your component, and the whole process and things will have to be brought up. So we'll talk about how Linux took care of it, but just to give you a pictorial view of how it is done. So as I said, each app is assigned a unique user ID on the system. Like here, there are two apps. They are provided the unique user ID. The process runs with this user ID and the group ID, and they will have access to their own resources, not anything outside the sandbox. Apps get to talk to each other, but in an explicit manner as you define in your manifest file. We'll see more details on this. Okay, but there was a need in enterprise domain for making two apps run on the same process and all. We'll talk in the other slides. But here what I'm trying to show you, when I said that whenever you request a functionality from another app, a new process has to be brought up by Android. So this is how it manages the speed, the performance of the system, that Android during startup will bring a process called Zygote. This Zygote process will bring up all the system services, make those system services accessible to other app in terms of manager. We'll have look at the APIs for this managers, and it will basically bring the process up, then the Dalvik VM, all the system services, and that's it. It will work. So it will sleep till the time you request or you launch an app wherein this process. So this process is forked out to run your app. So that's how it manages to give a nice performance on the device. That the whole process is forked out with a new process ID and the user ID, and then your app runs. Okay, as I was talking about, so automatically generation of the user ID. So this is how it looks like. On the older system, it used to be app and some 3-digit, but on the newer devices, it looks like this. So if you do a shell into your Android device, you connect your Android device with USB on your laptops, and you do a ADB shell, you get inside the device and you can run the Linux command. So like in this one, I ran ps command. So it shows you the user ID on which the internal or the app given by Google runs. So the Android email, the dialer, the calendar, and the desk clock. So those have been assigned the user ID by the system. Like in this case, U0A37 is assigned for the email application. Okay. Okay, just to give you a glimpse on how it looks like. So each app is given a small portion in the memory, which is under data, wherein you can go and look at all the files and folders that app is creating. So as you can see, if we do a ls into com.google.android.email, this particular app with the user 837. Okay, so you'll see that it's been so it's only accessible to itself and to the same group. Rest all don't have any permission except execute. So we'll see why. And you can see the databases, the files which this app is creating, the cache, and the app view. You won't be able to get into further into this, and you can't see this unless this app is running in the debug mode. But this is just to give you a glimpse how it will look like when you do a listing on this directory. So all the app will be given a space, which is like under data, and the full package name of the app. Okay, so this is just to like have a close this topic that, okay, so each app runs in a sandbox. So like Android app, and these will be the components as we talked first, like so activities, services, broadcast receivers, and content provided, and the Dalvik VM, and all the resources are inside this process. No other app gets access to these resources by default unless you make two apps run in the same process. We'll see how. Okay, another nice thing which I must to say is that regardless of whether you use native or Java source code, your sandboxing works perfectly fine with any of the development platform, whether you develop inside Java or C++. Your app is sandbox and runs in the security settings like sandbox, which is shown here. Okay, as I was saying, that two apps can run in the same process, or they can share a lot of data which normally is not allowed. So apps that are signed with the same certificate can share data and can share the user ID, as well as can be made to run in a single process. They just need to specify the same shared user ID and the process. Let's see how you do it. Actually, you'll do it in Android manifest file. So this is a pictorial view on how it will look like if you have two apps granted the same Linux user ID. They will run in the same process, and each one can access the other's resources without trouble. Okay, this is a view of the Android manifest file. This is the topmost element inside Android manifest.xml file. So here I'm trying to show that you have a way you can specify the shared user ID, which will make two apps get the same user ID during runtime. And inside the manifest, which I showed earlier in this slide, inside this manifest, there will be a XML tag called application. If you want two applications to run under the same process, you'll have to give a string, a common string to these two apps to actually make them run on the same process. And the ultimate requirement is that the two apps should be signed with the same certificate. Okay, let's dive into, so we have talked about Android mobile operating system. We have talked about apps are developed in Java, they run in Dalvik virtual machine, and we have also talked about app sandboxing. Let's dive into how we actually create those apps. So Android gives you two platforms. One is Android Developer Tool, which is based on Eclipse, and the newer is the Android Studio, which is based on IntelliJ. So this is kind of phased out. Not much of the development is going on towards the Eclipse Android Developer Tools, which is kind of a set of a plugin which we use. There's one nice thing about the development platform we have for Android is that it runs on Windows, Mac, Linux. Unlike Apple, when you need an Apple machine to actually do the development. Okay. Okay, this is a kind of a quick glimpse on how it looks. We'll see this in the real time when I show you a sample app, building of a sample app. That when you have the Android plugin created inside your Eclipse, you'll see these two nice icons. One is to manage your SDK, another is to manage your virtual devices, the emulators. And there will be a new perspective here, which is DDMS. We'll talk about that. That basically means Dalvik debug something. We'll talk about, we will see in the slides. Okay, so once you're into the DDMS, you can see your devices which are connected. You can see the system logs here. You can browse files, not so much because it requires permission, but still you have some view on the files, the files and folders inside the device, and you can do a lot more. You can, as shown here, you can capture a screenshot out of the device. This is a nice feature because if you're working with devices from several manufacturers like LG, Sony, and Samsung, they have different ways of taking a screenshot on the device, which is kind of required during development, and it's kind of a hassle because you'll have to know for each of the manufacturer how they program to take the screenshot, and then this also varies with each of the versions of the devices from the same manufacturer. So that's where it kind of ease out to quickly open the DDMS and you can quickly take a screenshot of the device which is connected via USB to your laptop. Okay, so as I said, DDMS stands for Dalvik Debug Monitor Server. It's used to actually do like things which you would normally do with Java Console or another profiling tool. And also you can screen capture, you can spoof call and SMS. Okay. Okay, just to give you a quick view, if you go and create a sample app, we'll actually do this at the end of the presentation. But just to give you a heads up on what's created. So if you create a Hello World Android, there'll be a layout created. Layout will have your screen. This screen is laid out on the activity. So this activity is mentioned inside your manifest. When you tap on your app from your manifest, it reads which is the launcher activity, the main activity. It brings that up. This activity will get the layout, inflate the objects from the XML, and lay that out on itself. So this is how it works. We'll see in action. So this is just another screen to show you how it looks. So it's only this much of the code. So as I said, it will take the layout and it will set the view for itself to actually display that UI. Okay, this is how the SDK manager looks like. The reason why I showed you this screen is because specifically on Windows, if you want to connect your devices and you want to see them on your Eclipse, you need to open SDK manager and you need to install this thing, Google USB driver package, which will let you, and this is needed only in Windows, it's not required for your Mac and Linux systems. So it's required only for the Windows. You need to have the driver for your device, and then on top of that, this driver package to kind of enable the DDMS showing your device during debug. Okay. So you'll face this, but just a quick look. So you'll have to enable. So once you have installed the package which I talked about in the previous slide, you'll have to enable USB debugging on your device to actually get started. But the latest release of Android is so simple that you connect it via USB, it will take you to that screen. But in case you're on the older versions, here is how you do it. So for the very old Android 3.2 version, you will have to go to settings, application development, check on the USB debugging, and you'll be all through. So this USB debugging will make sure that it automatically selects, so it automatically turns on unknown sources, which is required when you want to run the source, run your app from place other than Google Play Store. Okay, this is how you would do it in Android 4.0. So you will have to go settings, developer option, and check on USB debugging. Okay, this is how you do now, that you'll have to go on settings. To actually get enable the developer option, you'll have to do this. Go to settings, about phone, tap on the build number 7 times. Once you have done that, it will give you a small toast message saying that you are a developer now, and you will have this developer option enabled. It's only when you have done this step, you'll see the developer option, and then you will be able to go and say that you allow USB debugging. Just to show you how it will look like, so here I'm showing you the about phone, the build number. Once I have completed 7 taps, it will show me a toast. You are now a developer. Once I go back to settings, I'll see this developer options. Once I get inside developer options here, I'll get to check USB debugging. Okay. I talked about unknown sources. So previously unknown sources and the USB debugging were tied, but now those are separate. So you'll have to go inside security and say that you allow installing apps from sources other than Google Play Store. This is required during debugging. Okay. So as I talked about, we have to get into something wherein we understand the whole development platform. So what we get in terms of API, the system services, because those system services, you get access to them in terms of manager API. So we have to see the whole development stack to actually understand what we get out of Android. Okay, so we know is Android Linux kernel. Why Android? What Android did specifically to Linux to call it Android Linux kernel? We'll see. Then there are system libraries, the runtime, application frameworks. Those are the APIs which you get from Android. Then there is the SDK, which are the tools which will compile and compose your final APK. They are the apps which are native, which are given by Google. They are not so native. You can anyways replace them with something from Play Store or something of your own wish. Okay, so we know that Linux provides us security, like memory and process management, and they also provides you with file and network I/O and device drivers. On top of that, Android. Android is specific power management because so unlike for the other hardware when you have the AC power, here you depend on the battery. So it's kind of important for the device for the operating system to manage the power, the battery power. And then we need a way to actually have a shared memory. So although the apps run in their own sandbox, but we needed app to app communication. So there's a concept of shared memory, which will see low memory killer. So so a user can keep on spawning or launching the apps on the device. At some point in time, the memory is small on the small mobile devices. So the Android operating system will take care of killing the apps which are not in use or which have been there in the backstack for a longer time. So it will kill those apps to free up the memory for the other apps and the other system activities. Okay, IPC binder is it's a very nice feature when it's give an explicit way of two apps requesting services from each other. Okay. So as I previously said, you have system services, and those system services are made available in terms of API with these managers. So you have window manager when you can lay. I'm sorry. So you have Windows Manager when you can lay your UI, and you have Package Manager which you actually manage your app. Activity Manager is with which you manage the activity, the pages. The Location Manager will give you access to the location and movement data. Notification Manager lets you create notifications so that those are shown on the notification bar at the top of the device, which is other than the app on the screen. You can have access to the vibrator manager. I kind of missed that to show here. And same way you have alarm manager, content provider, resource manager, telephony manager to get access to the to other apps or to the native functionality of the system. So okay, this kind of a screen came back just to show you how this all works. So this is the same thing as I talked about Zygote here, when it will spawn one, sorry, it will spawn one process and the others are forked from the first one. So to speed up the whole process. The reason why I shown here is that during system startup, all the services are brought up, and these services are called system services. The access to the system services are via the managers, which I talked about. So managers are the API which you will actually use in your app to get access to the system services. Emulators. So emulators are cool because they get you your app tested quickly. Maybe you have a couple of Android devices when you do development on Android, but you'll not have all versions and flavors, and maybe you have a mobile phone but not a tablet. So emulator help us there when you can quickly have a system image downloaded and you can run. So system images are given by Google, and they are for both the platform like ARM and Intel. So you can get the system image with, and you can configure the the actual hardware footprint of that system image by setting the memory, by setting the SD card, and by setting the actual OS version on the system image. So let you do lots. There's a small caveat here that Android emulators are slow. Okay. So when you're creating emulators, you'll get into this wherein you need to know about this small names wherein VGA, video graphic array. Q is for the quarter video graphic array, the half video graphic wide, full wide video graphic array. So it's more on the pixel density on the device. So try to be at the QVGA because, or else if you take a higher density pixel system image, it'll take a lot of time to bring up and shut down. So It will save you a lot of time if you stick with the low DPI devices or the system images. So just to give you the advanced techniques, how actually, so your app need to be tested under various conditions of the device. Like for example, when there's a low battery or you're connected to a lower end network. So those kind of things can be spoofed on the emulator with which you can test your app. So you can test your app against those conditions right within the Android emulator. Okay, so this shows the emulator screen which I brought up in my laptop, and you see on the title bar there will be a 4-digit number which is the actual port number on which this emulator is listing. You can do telnet. You'll have to enable telnet on your Windows machine. Then you telnet localhost the port number which you are seeing on the title bar, and you're through. You can send commands to the emulator to actually mimic a condition on which you want to test your app. Like in this case, I'm showing a help so that it gives you a good or quick idea on what all is possible with this emulator, like telnetting to this like emulator. Okay, in this command, I'm setting power capacity to 100%. If you compare it with the previous image, the battery charging is showing less. I can say that power capacity to 100 as a command. Once I hit enter, it'll make the battery to be fully charged. And you see a small thunderbolt icon there, which means the battery is shown charging. So let's see how you can change that. So you can say power AC off, so the charging is taking out. Power status, or you can have you can actually use either one of this to actually say that I'm not charging, the device is not charging. You can bring the power capacity back to 5% maybe, so that it shows that battery is low. Now you can run your app and test inside the emulator against the low battery condition. Like I said that so actually this emulator will get access to whatever network you have on your laptop, Wi-Fi or LAN. But say if you want to actually, so you want to emulate a low network and low speed network for testing your app functionality, how it will work. So you can actually use the network command, and you can set the network speed to edge. Okay, if you don't know about edge, edge is enhanced GPRS, and the maximum speed possible is 473 kbps. This is far more than what you see in the real time. So you can set it to the lower network speed and you can test your app. You can bring it back to the full, whether it's 3G or 4G. So it will bring back to the full. And you can also spoof you can also spoof the device so that you can test your app against what happens when there's a SMS sent to your device. So you can send SMS. Okay, you can mimic that you have received one SMS here. So you say SMS sent is coming from this number. How are you doing, guys? So how are you guys doing? So so the device, this emulator will show as if there's a incoming SMS on this emulator. And you can make two emulators work together. So you can dial the number which you see on the port number which you see on the title bar. You can have that number dialed from another emulator on the same machine, and it will mimic like you are getting an incoming call. And it works kind of seamlessly here. So you can see one is shown as dialing, other one is shown with incoming call. If you pick, both are shown as call in progress. If you put on hold, both will be shown as put on hold. Okay, so this is how the Android emulator works. There are far more you can do. You'll have to through the command help command, and you'll get the list of the commands which you can fire and mimic a lot of things under which condition you want to test your app. Okay, let's get started with this cool app from Android from Google. So Android Device Manager. It's a kind of a security app, kind of needed. So Android Device Manager is a Google app that allows you to track and secure your device. What if you lose your device someday? So this app will save you a lot. So this app actually lets you track down your device on the map, cause it ring. You can completely wipe it. You can lock it remotely from your laptops if you have lost it. So these are the commands which you can fire from online, which is google.com Android Device Manager. There's an easy way to do it. Actually, you just have to type. Let me see. So these are the commands. Okay, so if you go to Google, you can simply type find my phone, the command, and the Google will find your device. So say that you have already put your Google account inside the device app and you have enabled Android Device Manager. When you type find my phone on the Google search, you'll be taken directly. So it will identify that with your account, it will identify that there are some list of devices attached. It'll try to find that device so that you can select which one device and it'll try to locate your device. You can do commands right from in here, or you can go to to the actual web app where Google lets you throw more commands. Okay, how to enable device, so Android device administrator. So you'll have this Google settings now. So Google settings is to control all the Google's apps which are installed on the device. Is one place where you can manage the setting for all Google apps. So you get inside Google settings, you will see Android Device Manager, and this by default is checked so that you can locate your device. But in case you want to give commands to your device from remote, then you'll have to enable this checkbox which says that allow lock and erase remotely. So when you click on that checkbox, it will ask you to activate it because it's a user giving permission to this app, saying that this app can go and erase all data, change the lock password, and lock the screen required. So you activate it, it's checked. Then you go to Android Device Manager. You remember I showed you in the previous screen. So it could be google.com Android/device manager, or it could be android.com device manager. Then you see the commands which you get to get against your device. You can click on ring to make your device ring, or you can lock. When you say lock, it will ask for a new screen password. You give that password, that's done. When you hit enter on the screen there, your phone is locked with that passcode. This is end of part 1. Hope you enjoy.